Okay, first things first with trig. We have to remember the special little phrase, SOHCAHTOA, which basically means the sine of an angle is opposite over hypotenuse. The cosine of an angle is adjacent over hypotenuse. And the tangent of an angle is opposite over adjacent. So that's what the S is for sine, the C is for cosine, the T is for tangent. We're going to start by talking about tangent, and I'm going to need to scroll down a little bit here. So to do tangent of S, that means we're looking from angle S. Tangent is not something on its own. It has to be tangent of something else, one of the angles. And so in this case, we're looking from S, tangent of S. Tangent of S, or tangent in general, is opposite over adjacent. So we're going to look opposite of S first, which is 80. Opposite of S is 80. And adjacent to S is 18. So tangent of S is 80 over 18, or we can reduce that to 40 over 9. Now, when we're doing tangent of R, it's the same steps, but we're looking from R instead. So when we're finding opposite of R is 18. And adjacent to R is 80. If you're not sure which one's adjacent, just remember it's easy to know which one's opposite because it's across from the angle. And the hypotenuse is always across from the right angle. So 82 was going to be the hypotenuse whether we were looking from S or R. So for tangent, we never use the hypotenuse. So when we simplify 18 over 80, that's just 9 over 40. All right, so here's how we apply that in order to find a missing side length. So before, if we had a missing side length, the only way to find that was if we knew two sides of the right triangle, we could use the Pythagorean theorem. Or if it was a special right triangle, like a 30, 60, 90, or 45, 45, 90 right triangle, we can use those special rules. In this case, the angle that it gives us is 56 degrees. So we can't use the Pythagorean theorem because we don't know the hypotenuse. And we can't use a special right triangle because this is not a special right triangle. So that's when we use right triangle trig. Your first step is to decide if you need to use tangent, sine, or cosine. And I told you we're starting with tangent here, but let's talk about why. So the x, what you're trying to find, is opposite of the 56. And the 13 is what's considered adjacent to the 56. So out of sine, cosine, and tangent is the one that uses opposite and adjacent. So that's why we're going to be using tangent here. So we would say tangent of 56. It's always tangent of the angle. So far we've used a letter to represent the angle, but this time we know the angle measure is 56. Equals opposite over adjacent. Now we're going to solve this problem just like we would solve any algebra problem. If I'm trying to get x by itself to get rid of the 13, I'm going to multiply both sides of the equation by 13. So in your calculator, you're going to take 13 times tangent of 56, and we'll get about 19.3. So that missing side length is 19.3. Make sure your answer makes sense. If we would have gotten something like 0.12, that doesn't seem reasonable considering that this side length was 13. So make sure your answer makes sense. And if it does, then you probably typed it into your calculator correctly. So let's look at another example of that. This time the angle it gives us is 61 degrees. So again, we can't use a special right triangle here. The 22 is opposite, the x is adjacent. So when we set up tangent, we would have tangent of 61 equals opposite over adjacent. This particular problem is a little bit trickier because the x is in the denominator. So when we're trying to solve for x, it's actually going to take us 2 steps to get there. First, we don't want the x in the denominator, so we're going to have to multiply both sides by x first. So we have x times tangent of 61. And remember, tangent of 61 is just a number. If it's helpful to you, what you could do is type in tangent of 61 in your calculator. I'm going to go ahead and do that on mine. And I get like 1.8040. So I could, if it's helpful to you, you can substitute this with 1.8040. If you want. Use 4 decimal points if you're going to do it that way. Or we can just go ahead and keep solving for x. We want to get rid of tangent of 61 and its multiplication, so we're going to divide. So in your calculator, you could also take, got too low there, 22 divided by tangent of 61, and we get about 12.2. So that missing side length was about 12.2. Again, make sure your answer makes sense. In this case, it does. Let's do another one real fast. 32, not a special right triangle. That's opposite. This is adjacent, so we're using tangent again. Tangent of 32 equals opposite over adjacent. The x is in the denominator. These are the ones that are a little bit trickier. It takes 2 steps. First, we multiply both sides by x. Then we divide by tangent of 32 to get the x by itself. And on your calculator, if you take 11 divided by tangent of 32, you should get about 17.6. All right. Every time there's a word problem in geometry, helpful to draw the picture, especially for these. So we have a surveyor standing 30 feet from the base of a tall building. So I need a building and I need a surveyor. That's a very tall surveyor. Okay, he is 30 feet away. So that's 30. The surveyor measures the angle of elevation from the ground to the top of the building. So this is the angle of elevation. We'll talk more about that another time. That's 65 degrees. Find the height of the building. All right, so the angle we know is 65 degrees. This is the opposite. This is the adjacent. So we're using tangent of 65 equals opposite over adjacent. And if I'm going to solve this to get h by itself, I multiply both sides by 30. And I get that the height, when I take 30 times tangent of 65, is about 64.3 feet is the height of the building. All right, now let's add in sine and cosine. So let's start with a refresher. We'll do, let's do angle S stuff first. We'll find sine of S and cosine of S to start. So sine of S means we're looking from S. Remember, sine is opposite over hypotenuse. So opposite of S is 63. The hypotenuse is 65. Cosine, so toa, cosine is adjacent over hypotenuse. So adjacent to S is 16. Hypotenuse is 65. So there's my sine of S and cosine of S. Now let's do the same thing from angle R. Remember, we never do it from the right angle, only the acute angles. So sine of R, sine is opposite, 16, over hypotenuse, 65. Cosine is adjacent over hypotenuse. And then I want you to notice that the sine of S is the same thing as the cosine of R. And the sine of R is the same thing as the cosine of S. So if I were to substitute these with like numbers, this is not going to be accurate. I'm just making up numbers here. If this is 70 degrees and R is 30 degrees. That means the sine of 70 degrees equals the cosine of 30 degrees. You can even check that by putting it in your calculator. I made up the 70 and 30, but even if you type in sine of 70 degrees, you get about 0.93. Well, it rounds up. We'll just do 9397. And then if I do cosine of 30, oh, that did not work. Oh, goodness sakes. Silly Mrs. Taylor. Okay. Why didn't it work? Because the angles of a triangle have to add up to 180 degrees, not 190 degrees. So I should have said sine of 70 is equal to cosine of 20. I guess I don't have to erase all of that. So cosine of 20 degrees, you should get that same answer. Goodness sakes. And I do. Okay. So, the application of that. We know if it's a right triangle, one of the angles is 90 degrees. If one of the angles is 56 degrees, then the other angle must be 34 degrees because the two acute angles need to add up to 90 degrees so that the three angles together adds up to 180 degrees. So the sine of 56 is the same thing as the cosine of 34. And you can check me on that by typing it into your calculator. Same thing over here. The cosine of 23 degrees would be the same thing as the sine of, what's 90 minus 23? 67 degrees. And again, you can check that on your calculator. Okay, a few more examples. So let's put it all together now. We're looking from 26 degrees. I'm going to go ahead and label all of these. This is my opposite. This is my hypotenuse, which makes this my adjacent. You can only find one variable at a time. So if I'm going to find x first, I'm going to be using opposite and hypotenuse. And if I'm using opposite and hypotenuse, let me write it. So katoa up here again. Opposite and hypotenuse means I want to use sine. So sine of 26 equals opposite over hypotenuse. So I'm going to to solve that, I'm going to multiply both sides by 14. (14) times sine of 26 is about 6.1. All right, now if I'm finding the y, let me use a different color for y, then I need to use adjacent and hypotenuse. So then I'm going to use cosine because cosine uses adjacent and hypotenuse. So cosine of 26 equals adjacent over hypotenuse. For this one, again, I'm going to be multiplying both sides by 14. This time we're taking 14 times cosine of 26. And we get that y is about 12.6. And make sure your answers make approximate sense. Same idea over here. I'll set them up, but I'm not going to solve them again. We've got opposite, adjacent, hypotenuse. So if I'm looking for t, I'm looking for opposite. I have hypotenuse. That means I'm going to be using sine if I'm looking for t. And if I'm looking for u, I'm going to need cosine for adjacent and hypotenuse. All right. We'll go ahead and solve these last ones. 49 degrees. This is my opposite. This is my adjacent. This is my hypotenuse. Let's do x first. If I'm looking for x first, I'm using sine. Sine is opposite over hypotenuse. So we're just multiplying both sides by 16 there. we get about 12.1. That's what I have written down. And then if I'm looking for y, that's adjacent over hypotenuse. Or I could, now that I know x is about 12.1, I could use tangent. Easier to use cosine, but I could, oh man, didn't mean to erase all that. Let me write it in real fast. This was 12.1. This was adjacent. I could use tangent here now that I know that opposite is 12.1. I could say tangent of 49 is opposite over adjacent. And then I could solve it the long way by multiplying by y. It won't always be immediately obvious which way is easier, but you'll get better and better at it. Oh, I like that color. Divide by tangent of 49. And I didn't do it this way on my paper. It should be close. 12.1 divided by tangent of 49. I get about 10.5 for y. And if I would have done it as, oh, not tangent, just 10.5. If I would have done it the other way using cosine, I also get 10.5. So that worked. Came out nicely.